So Zara has a side hustle selling zips, apparently. I wish I could make money selling zips, but here I am. So she's done some investigating, found that, the higher the price of a zip, the fewer zips are sold, right? It makes sense. Supply and demand. So, she's given us this table, right? Day one, price of a zip. So each day she's gradually increased the price of a zip to see what happens to the number of zips sold and to see the turnover, right? How much money she makes. So the first question is if these patterns, right? So 2D plus 5 and 101 minus 3D continue to be valid, is there any day where the turnover is exactly $445? So let's have a think. So the turnover is the price of a zip times the number of zips sold. And we can use, instead of numbers like 7, 9, 11, we can use the expression 2D plus 5 multiplied by the number of zips sold, 101 minus 3D. All right, so that gives us the turnover, and the question's asking, all right, that needs to equal $445. Awesome, so we're setting up a quadratic equation. All right, so let's expand out the left-hand side. 202D minus 6D squared plus 505 minus 15D equals 445. So minus 6D squared plus 187D, then subtract 445 on both sides, gives us plus 60 equals 0. Right, so we have a quadratic equation. We can solve for D, right, the day. And in this case, I'm just going to use my calculator. Menu, equate, F2 for polynomial, degree 2, minus 6 is A, 187 is B, and positive 60 is C. And we hit solve. So D will equal minus 0.3176, or D will equal 31.48. Great. So does that make sense? So the day that she'll get a turnover of $445 is negative 0.3 of a day. Okay, so that's, no, doesn't make sense. Or 31.48 of a day. So that kind of makes sense, right? 31 days and a half. However, in this context, the increment is a day, a whole day. If she was measuring like minutes, this could make sense, right? 31 days and then like about 12 hours minus a few minutes, yeah, sure. But in this context, D, number of days, needs to be positive, so greater than 1 or more, and whole number. All right, so it needs to be a positive integer. Therefore, neither solution is valid. Therefore, again, $445 is not a possible turnover. Amount for this given pattern. Right, in reality, the pattern won't be perfect and it might change and $445 might happen, but in this context, it doesn't. So just to summarize that one, because that was quite a lot, we used the pattern for number of zips and price of zips, multiplied them to get the turnover. We equated that to 444, and then got a quadratic equation and solved it to find out the number of days required to get a turnover of $445, and concluded it's not possible in this context. Now part 2. Zara finally realizes that not every whole number is a possible turnover value. Right, so she would have gone to level 2 calculus and done some algebra, work this out. But now we need to help her out some more and find 3 conditions, a specific whole number or a subset of whole numbers. So it could be not any whole number, but a whole number that meets these conditions must satisfy for it to be a possible turnover. Right? For example, we know that a turnover of $686 is valid because that happens when day is 1. Likewise, if the turnover was 855, that's also valid. So, just looking back at this question here, instead of equating it to this arbitrary amount, $445, let's equate it to this constant k, and then try solve. And in solving it, we'll realize that certain things need to be in place for it to become a whole number. So 2d plus 5, right, price of a zip, I think, and then 101 minus 3d, number of zips sold, will give us the turnover. In this case, we want it to be a whole number, k. And just like before, we can expand and simplify. So 202d minus 6d squared plus 505 minus 15d, and I'm just going to bring the k over, so minus k equals 0. Rewrite it in standard form. And in the previous question, we were able to do 505 minus 445. But here, this minus k is part of our constant term. So I'm just going to put brackets there to make it clear. And now when we're solving a quadratic that has some unknown constants in it, we can use the quadratic formula. So we'll have d equals, so just to clarify, a term, b term, and c term. A, b, and c. And a reminder, the quadratic formula is up there. So now what we're doing is substituting our values for a, b, and c, but in this case, c is actually in terms of k. So let's do that now. So negative b, so negative 187, plus or minus square root of b squared minus 4 times a, which is negative 6, times c, which is 505 minus k. Be careful to use brackets there. all divided by 2 times a, which is minus 6. Now let's simplify that a bit. Um, 187 squared. What is that? Menu, run. 34969. And here we have minus 4 times minus 6, which is positive 24. And then 24 times 505. 12, 12, 0. And it was 24 times negative k, which would give us negative 24k. While I'm here, let me just group these terms together as well. Four, 969. 47089. All over negative 12. Great. So D, like the solution for D, in terms of k, is this fraction here. Now let's have a think of what conditions we need for this expression to give us a positive whole number for D. Right, so we need 3 conditions. I think the most obvious one to me is have a think what happens inside the square root. Right, what don't we want it to be? Right, if that, it's called the discriminant, right? This 47089 minus 24k. If that's less than 0, we have square root of a negative number, which is a complex number, and days would not be complex. They will be a real number. So we could say for condition 1 that the discriminant, right, that expression under the square root sign, must be positive. And then rearranging for k, add 24k on both sides, divide both sides by 24. We'd find that k must be less than 1962.04. So we can't have a turnover that is greater than that and be a whole number, or like a real number, excuse me. D must be a whole number. So when we add or subtract this square root term, if that 47,089 minus 24k is not a square number, when we square root it, we will get a decimal number, right? And then we'd add that decimal number to minus 187, which would give us another decimal number divided by negative 12, etc. So we can conclude that the discriminant, again, this value here, 47,089 minus 24k, must be a square number. And we don't really need to explain too much further, because it's apparent if it's not a square number, the square root of a not square number will be a decimal, meaning D will also be a decimal number, which is not valid. And one final condition is, again, D must be a whole number, so the numerator must be divisible by 12. So the whole numerator must be divisible by -12 in this case. Because if it's not, then again we will have a decimal value for the day, which is invalid. So just to summarize this one, like in part 1, we formed a quadratic equation, but this time we had an unknown constant k. We then solved it using the quadratic formula. So here we couldn't just use our calculator because k is unknown, but using the quadratic formula, we got this expression, which we then reasoned different components of it to ensure d is a real number, it's positive, and it's a whole number.